Okay, guys, so we are going to look at, excuse me, IS number 14, part 2. This is the what does 95% confident mean part. So it says in this activity, you will use the confidence intervals applet. So if you want to click on that from the document, or you can go to the link that I posted under today's class materials folder. We're going to learn what it means to say we are 95% confident that our confidence interval captures the true mean, right? What does that 95% confident mean? So you can follow these instructions as well. Go to Stacklet and scroll to find confidence intervals. But once you get there, the page looks like this. Okay, so our next directions say to set the confidence level to 95% and the sample size to 5. So we're going to change our confidence level here. It's already at 95, that's nice, but sample size needs to go down to 5. So I guess that's as low as it goes. Okay, so now it says click sample to choose an SRS. SRS, of course, stands for simple random sample, and display the resulting confidence interval. The confidence interval is displayed as a horizontal line segment with a dot representing the sample mean in the middle of the interval. Okay, let's see what that actually does. So we press sample, look at that. So we have this horizontal line. The dot in the middle is our sample mean, and it tells us that the green line is the true population mean. So looks like the sample mean was actually pretty close, but the interval was, fairly wide. Okay, so it says, did the first confidence interval capture the true mean? Well, yeah, it did, right? So we can go ahead and answer here. I'm going to try to put my answers in red. Yes, it did. And then it says to repeat this 10 times and sketch what you see to the right. How many of the intervals captured the true mean? Okay, so we're going to go over here. I'm going to press sample 10 more times. 1, 2, 3, 4, 5. Notice as I'm doing this, I'm seeing other confidence intervals pop up here. They're all based on different sample means, so they're a little bit scattered here. Okay, that was 5, so 6, 7, 8, 9, 10. All right, so even though this one just barely looks like it caught that green line representing the true mean, I think all 11 of those did. You can see over here that it says hit 11, total 11. So out of the 11 samples I took, 11 of them hit the true mean. Okay, so let's answer that. How many intervals captured the true mean? Oh, red, sorry about that. So all of them did, okay. And then I'm just gonna screenshot this real quick so that we can see, hopefully this will fit within our space that I have delegated for it. So I'm gonna copy and paste that in here in just a second. So then it says reset and then take a total of 100 confidence intervals. So the sample 25 button we'll have to press 4 times. And then we're gonna look at how many out of the 100 captured the true mean and whether that's surprising. Okay, so we're going back to our page. We're going to hit the reset button. And now we're gonna hit sample 25 4 times. So that's 25. There's another 25. I can't see them anymore, but if you notice the total now says 50. Another 25 to get to 75, and one more 25 to get to 100. Hopefully you noticed this when we went through that, there were red ones popping up, and if you look, it's not covering that green line. So the red one is the one that missed. Okay, so it says hit 97 out of 100, which of course means the percent hit is 97%. I knew it wouldn't be exactly right the time that I did it to record. Last time I did it, it was exactly 95%. But that just goes to show us that 100 isn't a very big number. So even at 100, we're not gonna hit exactly our 95%, but if we did this thousands and thousands of times, 95% of them would hit. All right, so our answer here is how many out of the 100 captured the true mean, and is that surprising? So out of 100, 97 captured the true mean. I'm gonna maybe even put in here that 97 of the confidence intervals capture the true mean. So 97%. This is not surprising, right? This is a 95%. Since this is a 95% confidence interval, and 97% is very close to 95%. All right, let's do it one more time just to kind of get a feel like would this happen again. So I'm going to reset and I'm going to do that simple 25 4 times again. Yeah, that time I got 99%, right? If I do it again, maybe I'll get under 25 this time. 97% again. Just trying to prove me wrong. I think a great example of how randomness can be really streaky. Ah, that one, we only got one more. We got 92%. There we go. We got under 95%. So I just wanted to give you an example that different sets of 100 can give us different results, but they're all going to be right around 95%. And if I did this, a ton of times, I'm approaching and getting much closer to 95. Look at that. Okay, I've done it 1,050 times and I finally got to 95%. But again, 1,050 really isn't that much in the grand scheme of things. Okay, so going back to our instructions, it says watch your confidence intervals as you drag the confidence level from 95% to 99%. It actually says don't reset, so I guess I messed that up. I should go back to just 100. Okay, so look at that. We have 97% again. That works. And it's asking us to come up here to the confidence level and to drag that to 99. There we go, 99. Notice it's not going to let me do 100%. If I wanted to be 100% confident, my interval would be infinite. But I hope you noticed that when I went from 95 to 99, the length of the intervals increased, that they got longer. So I'm just going to show you one more time. Go back to 95, they got smaller. Up to 99, and those intervals get bigger. That red one that was missing the population mean, as I go up to 99, it's now hitting the population mean, right? It's a longer interval. It's more likely to hit them, or to hit the population mean. So why does this make sense? Well, in order to be more confident, we have to include more values in our interval. So if we want to be more confident, interval gets longer. Okay, so let's phrase that. What happens to the intervals when the confidence level increased? The intervals get longer. This makes sense because in order to be more confident, we have to include more possible values. All right. So now it tells us to actually reset and sample 100 times at an 80% confidence interval. So this is close to what we were talking about in that first part. Although we just made up the value of 80%, you'll get a chance to see that a lower confidence level is going to change our confidence interval length. Okay, so let's reset, and I'm going to change my confidence level all the way down to 80. Notice 80 is the least it'll let me do, because if you're wanting a confidence level less than 80, it's probably not very useful. So 80 is about the lowest confidence level we'll use. And I wanted 100 samples. So, okay, we're sampling to get 100. Look at that, percent hit is 86, 86%. But notice these intervals are shorter, right? These are considerably shorter than the ones we looked at earlier. Let's see if I can show you that real quick by looking at our screenshot from earlier. Oh, that is not the right screenshot. Where did it go? Maybe I didn't. Oh, here we go. Sorry, today at 5:12. All right, there we go. That's what I'm trying to look at here. So when we compare the lengths of those intervals to the ones we were just looking at, these are shorter. Okay, so let's phrase that. Oh, how many intervals capture the true mean? Sorry, it was 86% we saw. Wasn't that right? 86%? 86%. Okay, and so now it's asking us to interpret the confidence level. Now, this is different than interpreting the confidence interval. Please note that, right? We're not interpreting the confidence interval anymore. Now we're interpreting the confidence level. Okay, so let's type it out. All right, so if we make many, that many is coming back. Again, we're talking about more than 100. We're talking about a lot. So many, and then I'm leaving a blank to fill in what percent confidence I want. So for us, actually, I won't leave it blank. I'll just underline it. This is an 80% confidence interval. There we go, 80% confidence intervals. Many of them. We expect about, and again I'm saying about because 86% wasn't exact, but about 80% of them to capture the true mean. And I say capture the true mean because, again, the mean already exists. We're just seeing if our estimate actually is able to capture it. Okay, so that is our interpretation of confidence level. So now it says, now see what happens when we adjust the sample size. So there are two main things going on. We can change our confidence level. We could be more confident or less confident. More confident means we're going to have a wider interval. Less confident means we're going to have a narrower interval. Or we can adjust the sample size. Right now we're talking about a sample of just 5. That's pretty small, right? So if we change the size from 5 to 50, that might improve things for us. So let's try. We're just going to change it from 5 to 50 and sample for one interval. Reset. And I'm actually going to go back to 95 just because 95 is a very typical confidence level. So confidence level of 95, and I'm going to change this to a sample size of 50. All right, take one sample. Notice how small my interval is. I can show you, right? I could change it back to 5. I have to take another sample again, pretty wide. Now, when I go back up to 50 and take a sample, that interval is much shorter. Okay, so it says then change it to 250 and sample for one interval. Excuse me. What happens to the interval when the sample size is increased? So let's see 250. So if I go to let's go. It's tiny. You can't even hardly see that interval, right? It got even smaller. So we can answer this question. Let's see. When the sample size is increased, the interval gets smaller or shorter, I guess, however you want to phrase that. And this happens because whenever we increase that sample, we saw this before with our sample mean distributions, increasing the sample size led to less variability. We're getting a better picture of the population, and so we have less variability. So we expect less variability, which of course would mean that we have a smaller standard deviation with larger sample sizes. Okay, so there we go. That's about it for interpreting our confidence levels. I am going to switch out of this screen capture mode and answer the back page for you in the next video. Okay.